the another example that is right here. This is E02. This is example 2 right now. So let's start. This is also a review problem, right? Now let's start. A single reinforced section has a width of 12 inches. So the B are given, that is 12 inches, and an effective depth. Effective depth means D. So D is 15 inches. FC prime 3000 psi and Fy 4000 psi, right? Calculate 40,000 psi. Calculate the design flexure strength. So this means what? This is a review problem, right? Because we have to find out Mn value. So because we see B is given, that is 12 inches. So here we see B is given, that is 12 inches, and effective depth is given, that is 15 inches. And we also see that FC prime, that is 3000 psi, and Fy is 40 psi, right? And what we need Mn value. So that's why it is a review problem. We have two cases in this example. Case number 1, we have to use 6 number head. So in first case we see we have to use 6 number head bar, while in second case we have to use 6 number 10 bar. Noting that this is US bar. So US bar means number 8 means 8 sutar, right? And similarly, this is not ACI designation, because ACI designation is different from the US designation. So we need Mn, and we have two cases. So let's start how we can solve this example. And right, first of all, let's start this example. So let me bring my whiteboard. Now, as in the previous example number 1, we see that we find out the value of A by using the area of steel Fy divided by 0.85 FC prime into B. So we have A's value. How we can calculate A's value? We know that how much bar we have, right? Let me check it. This is 6 number head bar. Here I am sharing you one of the most easiest formula for calculating the area of steel. So 6 number head bar. We have 6 number, and we have to multiply this the area, cross sectional area of 6 number head bar. So number head bar, if you want to calculate the area of steel, that is AB, any bar area, you have an easy formula. 6, the number of bar, that is 8 divided by 9 divided by 9 square. It will give you the area of that bar. Number of bar divided by 9 square. So that why we are using number 8 bar. So number 8 divided by 9 square. If you do this calculation, you will find the area of steel, and the area of steel in this case it will be 4.71 square inches, right? You can confirm this right from this table. Let me discuss this table. This table is also very important. I have to show you that how you can pick such data. You see we have bar sizes right here. This is US bars, numbers 3 to number 18. You see the nominal diameter of each bar. You see the weight of per feet, pound per feet, you see here. And here we have number of bars. So as we are using number 8 bar, and 6 numbers. So this is right. So we have to use this line, right? So the desired value is 4.74, and that's why we are choosing that value, right? This is 4.7, right? So 4.74, this is rounded. Remember, this table is standard table, but if you calculate from this, you will get 4.771, right? So these are nominal areas. This table gives you nominal areas, right? So let's see. We will start the example, right? We calculate the A value by using the area of steel, and the A value will be AS is 4.71, FY is 40, and 0.85. Here you have to plug the value of FC prime, that is 3 KSI. Remember, you have to make sure you are consistent with units. If you are using 40, then you have to 0.85. FC prime is now 3 KSI, right? Because we are using KSI units, and B is 12 inches. From this, you can easily calculate the value of A, and that value will be 6.16, right? Square inches. Now, further what we need here, we need the value of C. We can easily calculate the value of C by using A divided by beta 1. And we have to make sure that beta 1 will be, what will be the value of beta 1. So as our FC prime value is less than 4000 psi or equal to, so it is less than 4000, right? Because we have 3000, so that's why our beta 1 value will be 0.85, right? So just divide this dip by the beta 1 value, you will get the value of C, and the C value will be in this case 7.24 inches, right? After doing this, you will find out the strain in the steel by using the proportionality, as we do in the first example, by using the strain in concrete, that is 0.003, and we know D, that is 15. So just plugging all the values, you will get the epsilon S value, that is 0.00321, right? As you see, the bars are placed in one layer, right? Although it is not mentioned right here, but we are assuming that the bar are placed in one layer, so that's why epsilon S equals to epsilon T, and what will be the value of, this is 0.00321, what will be the value of epsilon Y? We can calculate Fy, that is 40, divided by ES, that is modulus of elasticity of steel, that is 29,000. So if you divide this, you got the epsilon Y value, that is 0.00138. Now here you can clearly see this, that our epsilon T value is greater than the epsilon Y value. So that's why it suggests that our assumption, that is Fs equals to Fy, and this suggesting that the steel is yielding, right? Steel is yielding. Now, another thing which we have to make sure is the value of P, right? What will be the value of P right now? So as the bars are in one layer, that's why epsilon T value is equals to epsilon S value, and we already calculate the epsilon S value, that is 0.00321. But if we compare this, so we see here clearly that this value is less than 0.005. You can also do this check by another way, as we already discussed it, I think so, in part 7-8, I think so, that you can also check this by calculating the C over dt ratio. As we know the C value and we know the dt value, because d in this case equals to dt, and we know the C value, that is 7.24 inches. So if you divide 7.24 divided by the dt value, that is 15 inches, because here dt, noting down here, dt equals to d, because one layer of steel is using. If you divide this C over dt, you got the value. Let me divide this. .24 divided by 15 inches, we see 0.48. 0.48 is the value. Here we have 0.48, right? And as we know from that lecture part 7.8, that fc divided by dt is less than 0.375, is less than 0.375. This suggests that p value is 0.9. R, right? This suggests that p value is 0.9. So in this case, you see C over dt value is greater than, it is greater than the specified value. So we have to find the value of p. And similarly, we also know that fc divided by dt is greater than 0.6. I think so. Please check this. So in that case, p value will be 0.0. The p value will be 0.65. Right? But here we can clearly see this, that the value of C over dt is greater than 0.375 but less than 0.6. So we have to calculate the p value, and the p value equation will be used, that is 0.48 plus 83.3 into epsilon t, right? So you can either use, because I'm sharing those calculations which I have shared with you people in my lectures, right? We have do this in our lecture. So this is the another way. This is the another way that you can check this ductility check, or you can find out the p value. Or you can also use the same calculation as we did in the example number 1, that you have to compare the epsilon t value against the 0.005. So as in this case, this value is less than 0.005, right? And it is also greater than 0.002, because the epsilon t value which we have calculated right here is 0.00321, 0.00321, which is less than this value, and which is greater than 0.002. So this means we are in transition zone, right? This suggests that the section lies in this transition zone, right? This is the zone, this is transition zone. So here is the case, and here is the p value, which lies right in between 0.9 and 0.65, right? So we have to interpolate now the value, this p value, by using that equation which I have already shared, 0.48 plus 83.3 epsilon t. So if you plug all the values, what you got right here, epsilon t value will be 0.00321, So from this you will see the value of 0.747. now you see the effect, right? Because this time we are decreasing around about 25% the section capacity. Okay, we are not taking 0.9, right? Here if you are using p value 0.9, this means we are decreasing 10% the section design strength. But here this is around about 75, so we are 25% decreasing the section strength, right? After calculating this p value, this is what we say. I have already recorded a separate lecture on this, how to adjust a strength reduction factor. I have uploaded this. So this is called adjustment of strength reduction factor. Strength reduction factor, which is also called capacity factor. Strength reduction factor. This is very important how to adjust, because in later you will see in coming example we will use again and again this trick. So at this stage it is important for you people to understand this. Now we are able to find out the Mn value, right? Mn value is P times Fy into area of steel into B minus A over 2. We can know all the values. Here we have 0.747, not using 0.9. 40 times area of steel, that is 4.71, into D, that is 15, minus A divided by 2. The A value is 6.16. Do all the calculation, you will get the required result. What will be the value of if we ignore this value? Let me rub it this value, right? Let me rub this. So if you don't multiply that strength reduction factor, so the value, let's say we multiply this, right? I have do the calculation, so that's why please check it. The value will be 139.79 kf feet. So this value will be converted to kf feet, mean that you have to divide this by 12 and similarly divide it by 1000 to convert into inches. Now here you have to plug 40,000, right? 40,000, because if we are taking 1000, if you are using 40, then you don't need to use 1000, right? This is how we call consistent of units. And inches we are using, so convert it by 12, so you will divide it by 12, so to convert the inches into feet, right? So this is the way how we can solve this example. In this lecture we see that how to solve a review problem, right? So we cover the first case, that when we are using 6 number add bar. In next lecture, inshallah, that will be we will cover the second case, that when we have 6 number 10 bar. So don't miss that lecture, because that most important lecture, because here you can see some other things, because in that case you will see the section will go to some compression zone, and how to find out the Mn value when the section lies within the compression zone. I have already recorded a separate lecture on this. I think so that will be part 5, I think so. I will share the link in description, so please watch that lecture before starting this example. See you in next lecture. Thank you for watching.